Hello, welcome to a quick demonstration on how you can use the t-value to calculate the upper limit and lower limit of the class intervals. Now that sounds a little bit complicated, isn't it? But in this case, the data sample we're actually going to use is going to really be very helpful for us to kind of cement our understanding of what this actually means. Now, in this particular case, we have got restaurant sales, and we are trying to figure out how we can effectively come to grip with the variation in our sales, right, in different categories. Now, you'll notice here some preliminary work has actually been done so that we can spend quality time really focusing on the more challenging sections of the analysis. Now, here you see that here we've already done the simple means. We've calculated the averages for the different categories, so lunch sales, dinner sales, delivery sales, and also some averages for the weekdays as well as weekend sales. I think those are actually significant in understanding the restaurant sales. Then I've also done already some calculation on the standard deviation so that we can have some general understanding of what the data dispersion, how spread out the data is, right, between the different categories. And of course, did calculate the sample size. Now here, for illustration purposes, you can see here I used the average, which is the mean, and I used STDEV, which is standard deviation, and here I used the count to calculate the sample size for each data range. And then on the next one, I have alpha, right? So alpha is a very important statistical element that we need to understand, and it is the significance level that is used to compute the confidence level. So as an example, an alpha of 0.05 indicates a 95% confidence level. Right now, while a common value for alpha is normally 0.05, because many statistical applications, they tend to use the 95 confidence level as the default number, but it can be set at other levels such as 0.01 or 0.10, which means if it's 0.01, the confidence level is 99%. If it's 0.10, so the confidence level will be 90% respectively. So again, this depends on the type of analysis that is actually being performed. So you're likely to find, especially in scientific research, that you're likely to go with the alpha that is actually relevant to that type of analysis, where the results that will emerge from that particular analysis will be accepted as credible. That's the whole idea, right? So that's for the alpha explanation there. And you can see all I did was 1 minus 0.95, right? We know what the confidence level is, so 1 minus that. So in some cases, you can express this in percentages, or you can express it in decimal, right? So all you have to do is multiply it by 100 to convert to that. Now, what about the t-value, right? So the t-value in statistics is like a measuring stick that help us to see how different our sample data is from what we expect in a larger population. So it's like to tell us if the difference is big enough to be considered important. You can see there's some direct relationship between t-value and p-value, because p-value measures the statistical significance, whether we should reject the hypothesis or not. Right. So a high t-value means a significant difference, while a low t-value means the difference is small and not significant. So we use it to guide our decision making, in the process. In this particular case with sales, it's actually going to help us calculate what the upper limit of our sales is going to be and what the lower limit is going to be. But it has to be exactly the same value that you use to calculate the upper limit as well as the lower limit. So in our case, what we'll be trying to understand here is, here we can see what the average lunch sales are, dinner lunch sales are, and delivery, as well as the weekend, as well as weekdays. But now, because we have standard deviation there, it means that there is actually a sampling standard error that actually exists. So we're going to take that in consideration so that we are actually able to see the range of our sales, that even though the average, we see what the average is, but it can be lower than that, or it can be actually be higher than that. So that type of analysis can be very, very helpful in understanding our sales at a much deeper level. So there you have it. So that's why the t-value is a very important statistic that we need to use for that particular purpose, because without it, we won't be able to calculate the upper limit or the lower limit. So again, just revisiting what is upper limit. It's just the range right there, the highest possible sales we expect, and the lowest possible sales. So otherwise, in data analysis, upper limit and lower limit within the context of class intervals are normally used to define the range of values that are included within a particular interval or category, right? So it's the range of those values. So these limits, of course, are important for grouping data into meaningful intervals for analysis purposes. And in our case, it will be very helpful for us to understand the restaurant sales by category and see what is the range. So for planning purposes, then we'll be able to understand how much ingredients we need to have, and by how much should we err in order for us to still remain reasonable in terms of our estimates. Because in a restaurant environment, we have a lot of perishables. So if we order too much, we are likely to lose a lot. If we order too little, we are likely to lose sales, right? So it's either the perishables will go bad because they are leftovers, or if we don't order what is close enough, then we won't be able to save our customers, right? Because we will run out of those ingredients. So you can see that this type of analysis for this type of operation can actually come in really, really handy. So now that we have a grip on the working definitions of the alpha, the t-value, as well as the upper and lower limit, now we can actually go ahead and calculate the rest, right? So here, t-value. Now, t-value statistic can actually be read out of a table, right? So any statistics book or any finance book, accounting book is likely to have a table of t-values where you can actually read that. Or you can even go on the internet and actually look up any table for t-value. So in this particular case, I've just gone on the internet here, and I'm actually able to see there's actually a t-table available here for me. Right now, if I was going to go back to this here, I have to, for me to be able to read out the t-value that I want, I have to know what the sample size is. So we know the sample size is 26, and I also need to know the alpha, right? But then, of course, because I'm going to be working with a one tail, the alpha will be divided by 2, right? So therefore, the 0.05 becomes 0.0250. Okay, so now that I know, I'm going to be looking up, I'm going to be using the sample size 26, and the alpha is 0.0250. I can go back here and just try to read very quickly. Okay, so we know that the one tail line is going to be 0.025, right? So then I know that my sample size is actually 26, but degree of freedom is the sample size minus 1. So therefore, I use the raw number 25. So 25 and 0.025. I'm right here, right? So it's actually 2.060. So basically, I'm actually able to then read. It's going to be exactly the same t-value for the same sample sizes, but then of course it's going to be different. All right, let's say, for example, here I was going to say 2.060. It will be the same 2.060, 2.060. Right, and by the way, I'm just doing this for demonstration purposes, but then I'm also going to show you how you can actually calculate the t-value itself, just in case you didn't have access to any tables right? You still want to be able to complete a task like this. So now, just to demonstrate that the sample size is actually the driving factor in determining what the t-value is. So in this particular case now, we have a sample size of 16. So if you go back to the table, a sample size of 16 means that the degree of freedom is actually going to be 15, because 16 minus 1, and we have, what do we have here? So 15, and then we have 0.025. So 2.131. So it's 2.131. And then finally, sample size 10, we can go back to that. Sample size 10 means that the degree of freedom is going to be 9. So it's 2.262, 2.262. Okay, all right. So now that we've got this, what I'm actually going to do here, I'm going to demonstrate how you can actually calculate the t-value. So I'm actually going to use the next line so that you can actually compare and contrast and see that the numbers are actually going to be the same, generally speaking. All right, so how do we calculate the t-value? There is a function in Excel which is called t.inv, right? So that function returns the left-tailed inverse of the student's t-distribution. You can see here, it's actually highlighting that. So I can double click on it to activate the function, and then it says, what is the probability? So the probability is 1 minus, then I click on the alpha, divided by 2, because remember this is a one tail. As we looked up the values on the table, remember that we divided 0.05 by 2. So again, we do the same here. So comma, and then what is the degree of freedom, right? We remember when we're actually looking up on the tables, we're saying the sample size minus 1. So we know that's the sample size minus 1, closing parenthesis. And once we've done that, we can actually decrease the decimal. Maybe I want it to be to 4 degrees. Right, you can see here, we actually come to exactly the same. And then I can copy the same formula here, right? And I can also go ahead and copy the formulas. There, you can see that we actually match, right, by actually using the t.inv. Right, now that we've got our t-value, it's now time for us to calculate what is the upper limit. So we can calculate the formula for upper limit once and the lower limit once, and then we can copy that across. All right, so let's see here. So unfortunately, Excel does not have a function that is inbuilt. Right, so we actually have to figure out what the formula is supposed to be. So it's we say equal sign, so we click on the mean, right? So then we are saying we begin with the mean, and the upper limit will be plus the t-value, okay, multiplied by open parenthesis. So we multiply that by the standard error. Now the standard error of the sampling is actually derived from the standard deviation divided by the square root of the sample size. So basically, if someone was going to ask you, can you please go ahead and calculate the standard error, where you are actually given the standard deviation, as long as they've got the sample size, you'll be able to do that. Because basically what you're seeing here in parentheses, we are simply saying we are taking the standard deviation and we are adjusting it with the size of the sample, so that we can determine what the standard error is. And it's that standard error that we're actually multiplying with the with the new value that we got after adding the t-value to the average or to the sample mean. Right, so once we've done that, we are good to copy this across. But anyway, before we do that, we can go ahead and calculate also the lower limit. So the lower limit, again, as we did on the previous one, we begin with the sample mean minus, because here we want to find the lower value, right? The lower limit minus the t-value multiplied by open parenthesis, so our standard deviation, divided by SQR to the square root of the sample size, the closing parenthesis. Right, so then once we've done that, we should be able to copy this across, and we can copy this to the next section to use a fill handle. There we go. So now, what is the significance of these numbers, the upper limit and lower limit? Now, if we are trying to interpret these cells in totality, now we can actually begin to look by category. Let's say, for example, look at the lunch cells. We can see what the average cells are, right, for lunch cells. But now, the upper limit and lower limit is telling us that, well, the average cells are 486. They can be as high as 558 and can be as low as 415 because of this sampling error that is in the standard error that we actually used. Also, the same is true for dinner cells. Right, while the average is 1,092, it can be as high as 1,200, it can be as low as 932, right? And again, you may find that the gap widens depending on the standard deviation number you have there. So the higher the standard deviation, the more spread out the data is, which means the more difficult it is to estimate, right? Because there will be, in that particular sales range, it varies a great deal. So in other words, we're saying that for dinner sales, we are likely to get as high as 1,200 on a very good, during a very good week, right? But can be as low as 932. So then how do we plan, right? Right. So again, the larger our sample size, the closer we will be to reality. You're likely to find that when we've collected a larger sample of the data of our cells, we'll actually be able to, that gap will actually close, right? So the higher the sample size, the more accurate we are likely to be. But of course, if the sample is small, we have to factor that in, that sampling error in our standard error, so that we can adjust our estimates accordingly. So once again, you're actually able to interpret this for every category, and we can also go to the weekend. Here we can see that weekdays are the most difficult to estimate because the gap is actually at its widest, right? And the easiest one, the more reliable estimate can be found with the lunch cells there, right? It's the smallest, and while this is actually the largest. And of course, we can see that lunch cells are much more predictable than dinner cells, and of course, and delivery cells, and also weekend cells are much easier to predict as well, right? As we can see that the data dispersion is a little bit lower there as well. So you can actually see the power of the t-value to enable you to analyze your sales data in a way that you'll be able to develop some deep understanding of the patterns that actually emerge from your data. But of course, you have to bear in mind that there are many other statistical measures that we could as well have used as well to give us some different perspective about our data, so that we can develop some deep understanding for our data. I mean, this would include measuring the pickedness of the data, which we call kurtosis, or the skewness of the data, the more data of highest frequency, or what is the midpoint of the data, and so forth. All those can also explain some additional characteristics of our data. But this particular one, as you could see and appreciate, is really key to understanding how we can really help ourselves understand the data a little bit more so that we can use it for planning purposes. All right, otherwise that's all I have for you. I hope you found this demonstration useful. And again, please like, share, and be sure to subscribe. Thank you. Bye for now.